Hello friends, and welcome back to my channel, Deep Sleep History. Before we begin tonight's gentle journey, I'd like to ask you a few small questions. Where in the world are you listening from tonight? What time does your clock say right now? Is it late in the evening, or has the night already grown deep and quiet? Perhaps you're resting beneath a warm blanket. Maybe the lights in your room are still on, waiting for you to switch them off. If that's the case, now is the perfect moment. Dim the lights, settle into a comfortable position, and allow your body to relax. Tonight, there is nowhere you need to go, nothing you need to solve. For the next few hours, we'll leave behind the busy world of today and travel farther than almost anyone ever imagines. Not across countries, not across oceans, but across time itself. Together, we'll journey back nearly 4.6 billion years, long before the first tree stretched toward the sky, long before the first fish swam through the sea, long before dinosaurs thundered across ancient plains, and even before our own planet existed. The earth beneath your feet, the mountains, rivers, forests, deserts, and cities, was once nothing more than tiny grains of dust floating silently through an endless darkness. It is difficult to imagine. Everything you have ever known, every person, every animal, every drop of water, every grain of sand, every breath ever taken, all of it began from something so incredibly small that it would have seemed almost invisible. Tonight, we are going to witness that impossible beginning. So take one slow, comfortable breath and let your imagination drift gently backward, far beyond written history, far beyond humanity, far beyond life itself. Our story opens nearly 13.8 billion years ago with an event unlike anything that has happened since. The universe itself was born. There were no stars, no planets, no galaxies, no light shining across the darkness, because darkness itself had not yet become what we know today. Space and time were only just beginning. Within moments, the universe expanded with unimaginable speed. Tiny particles of energy raced away from one another as temperatures hotter than anything we could ever create slowly began to cool. Millions of years passed, then hundreds of millions. Gravity, the quiet architect of the universe, began gathering enormous clouds of hydrogen and helium together. Slowly, patiently, almost invisibly, those clouds became the first stars. Inside these brilliant furnaces, something extraordinary happened. Simple atoms fused together under crushing pressure. Hydrogen became helium, helium became carbon, then oxygen, then silicon, then iron. Every heavier element required incredible heat to form. But even stars have lifetimes. When the largest among them finally exhausted their fuel, they ended in spectacular explosions called supernovae. These explosions scattered newly created elements across the young universe like seeds carried by a cosmic wind. Without those ancient stars dying, there would be no iron in your blood, no calcium in your bones, no oxygen filling your lungs. In a very real sense, every living thing today carries tiny pieces of stars that lived and died billions of years before Earth was ever born. As time continued flowing, galaxies slowly took shape. One of them would become our home. Today we call it the Milky Way.
But back then it was still growing. Stars continued forming inside vast spiral arms, each surrounded by swirling clouds of gas and dust. One ordinary region of that galaxy would eventually become far more important than any other, at least from our perspective, because that quiet corner of space would one day give birth to the Sun, and with it, everything we know. About 4.6 billion years ago, something disturbed a massive cloud of gas and dust drifting through the Milky Way. Scientists believe the shockwave from a nearby exploding star may have pushed this cloud inward. Gravity immediately took over. Slowly at first, then faster and faster, the cloud collapsed upon itself. As it shrank, it began spinning. Just as a figure skater spins faster by pulling in their arms, the collapsing cloud rotated more quickly. The center became hotter, brighter, denser. Around it stretched an enormous spinning disk made of gas, ice, rock, and microscopic dust. This was no ordinary cloud anymore. It had become the birthplace of a brand new solar system. At its center, pressure climbed to unimaginable levels. Temperatures reached millions of degrees. Finally, hydrogen atoms began fusing together. A new star ignited. Our sun had been born. Its first light spread across the surrounding disk, illuminating billions upon billions of tiny particles, each one no larger than grains of sand. Yet every mountain, every ocean, every continent, Every future living creature would eventually grow from these humble beginnings. At first, those tiny particles simply drifted around the newborn sun, but they did not remain alone for long. As they gently collided, some stuck together. Small pebbles became larger rocks, rocks became boulders, boulders became enormous bodies stretching hundreds of kilometers across. The process was unbelievably slow. Millions of years passed, then millions more. The young solar system was anything but peaceful. Objects crashed into one another constantly.
Some collisions shattered growing worlds apart. Others helped them become larger. It was a chaotic dance of gravity, fire, and endless impacts. Somewhere within this crowded disk, one particular collection of rocky material was quietly becoming something extraordinary. Not yet a planet, not yet recognizable, just another growing world among many. But it would soon become our home. And in the next chapter of our journey, those countless collisions will transform that glowing young world into the planet we now call Earth.
As our story continues, imagine yourself floating silently above the newborn solar system. The brilliant young sun glows at its center, still far more restless than it is today. Powerful bursts of radiation stream into space, illuminating an enormous spinning disk of rock, metal, gas, and ice. Nothing here is calm, nothing here is gentle. Everywhere you look, worlds are being born. Some will survive, many will disappear forever. The young solar system is like a giant construction site, except every building block is traveling thousands of kilometers every hour. Within this swirling disk, countless rocky bodies continue colliding. Some are no larger than pebbles, others have grown into mountains floating through space. Every impact changes their future. Most collisions are violent enough to break objects apart, but occasionally gravity wins. Broken pieces remain together. Tiny worlds slowly become larger ones. Over millions of years, one growing body begins to stand out. It circles the young sun at just the right distance, not too close to be swallowed by unbearable heat, and not too far to remain forever frozen. At this point, however, there is nothing beautiful about it. There are no oceans, no continents, no blue sky, no clouds drifting overhead. Instead, this young world is a blazing sphere of molten rock. Its surface glows orange and red, brighter than the hottest lava found on Earth today. Imagine standing nearby.
Of course, no human could survive for even a fraction of a second. Temperatures reach well above 1,000 degrees Celsius. Rivers do not flow here. Instead, entire oceans of liquid rock slowly move across the surface. Everywhere, volcanoes erupt without pause. Mountains rise only to collapse again beneath endless impacts from space. For millions of years, giant asteroids and planet-sized objects continue crashing into the growing Earth. Each impact releases more energy than billions of modern nuclear weapons combined. Every collision melts fresh layers of rock. The planet can barely cool before another impact arrives. Yet these seemingly destructive events are quietly building the Earth from the inside out. Gravity pulls the heaviest materials toward the center. Molten iron and nickel slowly sink deep beneath the surface. Lighter rocks float upward. Without anyone watching, without any guiding hand, Earth begins organizing itself. A dense metallic core forms deep inside. Around it develops a thick mantle of slowly flowing rock. Above that, a thin crust starts appearing whenever the surface cools, only to be broken apart again by another tremendous impact. Even today, billions of years later, that hidden iron core still protects us. It creates Earth's magnetic field, an invisible shield that deflects much of the dangerous radiation constantly streaming from the sun. Without it, life as we know it might never have existed. But perhaps the most extraordinary event in Earth's early history has not happened yet.
Roughly 4.5 billion years ago, another young planet is traveling through the inner solar system. Scientists call this lost world Theia. It may have been about the size of modern Mars. For countless years, Theia follows its own orbit around the Sun. Then, little by little, gravity changes its path. Its orbit drifts closer and closer, until one unimaginable day, the two worlds meet. The collision is almost beyond comprehension. This is not a simple crash. It is one planet striking another. The impact releases an amount of energy almost impossible to imagine. Much of Earth's outer layers are blasted into space. Theia itself is almost completely destroyed. For a brief moment, our planet is surrounded by an enormous glowing ring of vaporized rock and molten debris. If anyone had been there to witness it, the sky would have looked like a river of fire circling the wounded young Earth. Yet even this disaster becomes the beginning of something beautiful. Gravity once again begins its patient work. The scattered debris slowly gathers together. Countless fragments collide gently. Larger pieces form, week after week, century after century. Thousands of years become millions. Eventually, those fragments merge into a single companion. Our moon is born. At first, it orbits much closer than it does today. It appears enormous in Earth's sky. Its gravity pulls strongly on the young planet, slowing Earth's rapid rotation and helping stabilize its future climate. Even now, billions of years later, the moon continues drifting away from us by about 4 centimeters each year. Very slowly, almost too slowly to notice, our closest celestial neighbor is still moving further into space. Back on Earth, conditions remain incredibly hostile. Asteroids continue falling. Volcanoes pour rivers of molten rock across the surface. Thick clouds of steam, carbon dioxide, methane, sulfur gases, and volcanic ash blanket the entire planet. Sunlight barely reaches the ground. There is no blue sky, no birds singing, no gentle breeze.
Only darkness, lit by glowing lava and constant lightning flashing through enormous storm clouds. The Earth is still alive with violence. Yet hidden within all this chaos, change is quietly beginning. The relentless bombardment from space gradually becomes less frequent. The surface begins cooling for longer periods. The first solid crust survives just a little longer than before. Deep beneath the thick clouds, something remarkable is preparing to happen. Water vapor fills the atmosphere in astonishing amounts. For millions of years, it has remained trapped as steam because the planet was simply too hot. But temperatures are slowly falling. Not quickly, not dramatically, just enough. Soon, the skies above this ancient world will experience rain unlike anything Earth has ever seen since. Not for hours, not for days, not even for years, but for millions of years without stopping. Those endless rains will transform this fiery world forever. And from those cooling waters, the next chapter of our journey will begin, the birth of Earth's first oceans. Some collisions shattered growing worlds apart. Others helped them become larger. It was a chaotic dance of gravity, fire, and endless impacts. Somewhere within this crowded disk, one particular collection of rocky material was quietly becoming something extraordinary. Not yet a planet, not yet recognizable, just another growing world among many. But it would soon become our home. And in the next chapter of our journey, those countless collisions will transform that glowing young world into the planet we now call Earth.
For millions of years, Earth had glowed like a giant furnace. Its surface had been covered by rivers of molten rock. Its skies had been hidden beneath enormous clouds of volcanic gases. But time, the greatest sculptor in the universe, never stopped working. Very slowly, almost too slowly to imagine, the young planet continued to cool. The thick atmosphere was now packed with an astonishing amount of water vapor. Every volcanic eruption released even more steam into the sky. Countless icy asteroids and comets that had collided with Earth over millions of years had also delivered precious water. At first, none of it could become rain. The air was simply too hot. Every tiny droplet instantly turned back into steam, again, again, and again. But eventually, the balance began to change. Temperatures dropped just enough for something extraordinary to happen. High above the dark volcanic clouds, the very first drops of rain formed. Imagine standing on this ancient Earth. Above you, the sky is nearly black. There is no blue horizon, no sunlight breaking through gentle clouds. Instead, towering storms stretch across the entire planet. Lightning flashes constantly from one side of the sky to the other. Thunder echoes over a world with no ears to hear it. Then, a single drop of rain falls, then another. Soon millions follow. What begins as scattered rainfall quickly becomes something almost impossible to imagine. Rain falls day after day, year after year, century after century. The storms never truly end. Scientists believe this incredible rainfall may have continued for millions of years. The water crashes onto glowing rocks, creating clouds of hissing steam.
Entire valleys disappear beneath torrents of water. Fresh lava cools almost instantly when touched by the endless rain. Where fiery rivers once flowed, streams of water begin carving their first paths. Slowly, depressions in Earth's surface start filling. Tiny pools become lakes. Lakes merge into enormous basins. Those basins grow larger with every passing millennium. The first oceans are beginning to appear. They are nothing like the oceans we know today. Their waters are warm, perhaps even boiling in some places. The color is dark, stained by dissolved minerals and volcanic chemicals. There are no fish swimming beneath the surface, no coral reefs, no whales singing in the depths, no beaches lined with soft golden sand. Only endless water stretching beneath a sky filled with ash and steam. The air itself is still impossible for humans to breathe. There is almost no oxygen. Instead, carbon dioxide, methane, ammonia, sulfur dioxide, and water vapor dominate the atmosphere. If you somehow stood here, you would not survive for more than a few moments. Yet despite appearing lifeless, something remarkable is quietly happening beneath those dark waters. The oceans become Earth's greatest laboratory. Every river washing across fresh volcanic rock carries tiny minerals into the sea. Iron, carbon, nitrogen, phosphorus, sulfur. These simple ingredients dissolve into the ancient oceans.
Far below the surface, the planet itself remains restless. Earth's interior is still incredibly hot. Seawater seeps deep into cracks within the ocean floor. There it is heated to extraordinary temperatures before rising back into the sea through towering hydrothermal vents. These underwater chimneys pour mineral-rich water into the surrounding darkness every single day. Some of them reach temperatures above 350 degrees Celsius. Yet because of the crushing pressure deep beneath the ocean, the water does not boil. Instead, it emerges as dark mineral-filled clouds that scientists now call black smokers. Around these vents, chemistry becomes astonishingly complex. Hot minerals mix with cooler seawater. Tiny molecules collide endlessly. They combine, separate, then combine again. No one knows the exact moment life first appeared. It remains one of science's greatest mysteries. But many researchers believe places like these hydrothermal vents may have provided the perfect conditions. The oceans protect delicate molecules from harsh ultraviolet radiation coming from the young sun. Minerals act as tiny catalysts. Energy flows continuously from Earth's interior. For millions upon millions of years, nature quietly experiments. There are no witnesses, no audience, only chemistry patiently exploring every possibility. Above the oceans, the moon appears much larger than it does today. Because it orbits far closer to Earth, its gravity creates enormous tides. Twice each day, vast quantities of seawater surge across the rocky coastline before retreating again. These powerful tides constantly mix minerals, chemicals, and fresh water, creating ever-changing environments where increasingly complex reactions can occur. Each sunrise reveals a slightly different world. Each sunset leaves behind another opportunity for change. Although no living creature yet swims through these waters, Earth is no longer simply a dead ball of rock. It has become something much more. A planet with oceans, a planet with weather.
A planet with cycles of evaporation, rainfall, rivers and tides. The foundation of every future ecosystem has quietly taken shape. Still, if you looked across the endless sea, you would believe nothing was alive. The surface remains calm, silent, empty. But hidden far beneath those ancient waves, among warm, mineral-rich waters and microscopic chemical reactions, the first fragile spark of life is drawing ever closer. And in the next part of our journey, that tiny spark will become the greatest turning point in the history of our planet. For the first time in Earth's long story, life will finally appear.
The oceans had now covered much of the young Earth. The endless rain had finally begun to slow. For the first time in our planet's history, there was a rhythm to the world. Clouds formed, rain fell, rivers carried minerals into the sea. The tides rose and fell beneath the watchful pull of the young moon. It was still a harsh and unfamiliar world. The air remained toxic, volcanoes continued to reshape the land, earthquakes shook the fragile crust, and deep beneath the oceans, hydrothermal vents released superheated, mineral-rich water into the darkness. Yet, compared with the violent chaos of Earth's earliest days, the planet had become surprisingly stable. Stability may not sound exciting, but throughout Earth's history, it has often been the quiet moments that allowed the greatest changes to happen. For millions of years, the oceans acted like an enormous mixing bowl. Every wave stirred chemicals together. Every tide carried minerals from one place to another. Tiny droplets evaporated into the atmosphere before falling again as rain, continuing the endless cycle. Some scientists believe the first building blocks of life formed deep around hydrothermal vents. Others suggest they may have formed in warm, shallow pools near ancient coastlines, where water repeatedly evaporated and returned, concentrating simple molecules. No one knows for certain. The truth has been hidden beneath more than 4 billion years of history. But regardless of where it happened, one thing is clear. The young Earth was no longer just cooling, it was becoming increasingly complex. Simple atoms had already become molecules. Now, some of those molecules began joining into larger and more intricate structures. Imagine millions upon millions of tiny pieces fitting together like an endless puzzle. Most combinations lasted only moments before falling apart, but every so often a more stable arrangement appeared. Then another, then another. Nature was patient. There was no hurry. It had millions of years to experiment. Some of these new molecules developed an extraordinary ability. They could help create copies of themselves. Not perfect copies, far from it.
Each new copy contained tiny differences. Some survived longer, others disappeared almost immediately. Without anyone planning it, the first hints of evolution had quietly begun. It was an incredibly slow process. A change that today might seem insignificant could take thousands of generations. Yet over millions of years, those tiny differences added up to something remarkable. The oceans became filled with microscopic chemical systems, growing ever more organized. Still, nothing here resembled the plants or animals we know today. There were no eyes, no mouths, no fins, no shells, no bones. Only microscopic structures, invisible without powerful modern microscopes. If you scooped up a handful of seawater, it would appear completely empty. Yet hidden within that water were countless tiny experiments taking place every second. Earth itself seemed unaware of the miracle unfolding. The sun continued rising and setting. The moon continued pulling the tides. Volcanoes continued erupting. Storms continued crossing the oceans. Everything appeared ordinary. And yet, perhaps somewhere beneath the waves, a tiny membrane enclosed a small collection of molecules. Inside that fragile boundary, chemistry became something more. Energy entered, waste left. Simple reactions became organized. Eventually, one tiny structure divided into two. Then those two became 4, then 8. For the first time in the history of the universe, on this little blue world, something had crossed an invisible line. It was no longer merely chemistry. It was life. These first living organisms were astonishingly simple. Each one consisted of only a single cell.
They floated through the ancient oceans, feeding on chemicals dissolved in the water. There was no oxygen for them to breathe, because Earth's atmosphere still contained almost none. Instead, they relied on chemical reactions very different from those used by modern plants and animals. To us, they would seem unimaginably small. Yet every tree, every bird, every dinosaur, every whale, every flower, and every human being would one day trace their ancestry back to organisms very much like these. It is a humbling thought. The vast diversity of life on Earth began with creatures so tiny they could fit by the millions inside a single drop of water. As countless generations passed, these microscopic pioneers slowly spread across the oceans. Some settled near hydrothermal vents, others drifted with the currents, A few adapted to warmer waters, while others survived in cooler regions. Each successful adaptation opened new possibilities. Life was no longer confined to one place. It had begun exploring its world. The oceans, once silent and lifeless, were now home to billions upon billions of invisible organisms. Although no fish swam through the waves and no seaweed swayed with the tides, the planet had crossed its most important threshold. Earth was alive. The change was almost impossible to notice from space. A visitor looking down would still see dark oceans beneath thick clouds. Nothing dramatic had happened overnight. There had been no sudden explosion of life. Instead, the transformation was gentle, patient, almost whisper-quiet. But from this point onwards, the history of Earth would never again be a story of rocks alone. It would become the story of life itself. And over the next hundreds of millions of years, some of those tiny single-celled organisms would discover a remarkable new way to gather energy, using the light of the sun. That discovery would slowly change the oceans, the atmosphere, and eventually the destiny of every living creature yet to come. Our journey continues in the next chapter, where sunlight itself becomes the driving force behind one of the greatest revolutions in Earth's history.
As our journey continues, the young Earth no longer feels completely empty. Its oceans stretch endlessly beneath thick grey skies. Volcanoes still rumble in the distance. Steam continues to rise from cracks in the ocean floor. The moon hangs much larger in the sky than it does today, pulling powerful tides across the ancient seas. Yet if you looked closely into a single drop of seawater, you would discover that our planet has quietly crossed the greatest boundary in its history. Life now exists. Not the kind of life we recognize today. There are no forests, no flowers, no fish gliding beneath the waves, no birds soaring overhead. Only microscopic single-celled organisms drifting through the warm oceans, invisible to the naked eye, silent, fragile, and completely unaware that they are the ancestors of every living thing that will ever exist. These first organisms are incredibly simple. Each one is little more than a tiny membrane surrounding a handful of important molecules. There is no brain, no heart, no eyes, no skeleton. Yet each cell performs something astonishing. It takes in energy from its surroundings. It grows.
It repairs itself, and eventually, it divides into two. One cell becomes two, two become four, four become eight. Given enough time, countless generations spread through Earth's ancient oceans. Every division introduces tiny differences. Most make no difference at all. Some are harmful, but every so often, a small change allows one organism to survive just a little better than another. Perhaps it gathers nutrients more efficiently. Perhaps it survives warmer water. Perhaps it tolerates stronger chemicals. Those tiny advantages are passed to future generations. This slow process is what we now call evolution. It is not guided by purpose. It has no final destination. It simply rewards what survives. Over millions of years, those tiny improvements accumulate. Life slowly becomes more adaptable, more resilient, more diverse. The oceans are still quiet from the perspective of a human observer, but beneath the surface, an invisible revolution is unfolding. Imagine drifting gently through these ancient waters. Every drop around you contains millions of microscopic organisms. Some float freely with the currents. Others cling to underwater rocks near hydrothermal vents. Many spend their entire existence without ever moving more than a few centimeters. And yet together, they are reshaping the future of an entire planet. Some of these ancient microbes begin forming thin layers across submerged rocks. Generation after generation settles on top of the last. The result is a strange living structure known today as a stromatolite. From a distance, these formations resemble rounded rocky mounts, but they are alive. Each layer is built by countless tiny organisms living together as enormous communities. Even today, rare stromatolites still survive in a few isolated places on Earth, offering us a glimpse into one of the oldest ecosystems our planet has ever known. If you were somehow able to visit those ancient shorelines, you would not find sandy beaches or waving palm trees. Instead, you would see broad stretches of dark volcanic rock covered with shallow pools. Within those pools, slimy mats of microbial life quietly grow beneath the sunlight. For hundreds of millions of years, these humble communities dominate the planet.
They have no predators, no competition from larger creatures. The Earth belongs entirely to microbes. Time passes almost beyond imagination. 10 million years, 50 million years, 100 million years. Still, life remains microscopic. To us, such an immense span of time feels almost impossible to comprehend. Human civilization has existed for only a few thousand years. Compared with the age of these early microbes, all of recorded history would occupy only the final few moments before midnight on an enormous cosmic clock. Nature, however, has always been patient. It never rushes. Every generation offers another opportunity for tiny improvements. One small change leads to another. Complexity increases almost imperceptibly. Then, somewhere among these countless microscopic organisms, an extraordinary innovation begins to appear. Instead of relying only on chemicals dissolved in the water, a few ancient microbes discover another source of energy. Above them shines the young sun. Its light pours across Earth's oceans every single day. Until now, that sunlight has warmed the water but accomplished little else. Soon, some remarkable organisms will learn how to capture that light itself. It is one of the greatest inventions in the history of life, a process so successful that nearly every breath you take today still depends upon it. But before we witness that remarkable transformation, picture the Earth one last time as it exists now. Dark oceans, grey skies, volcanic islands scattered across the horizon, microscopic life quietly covering ancient rocks. No forests, no animals, no oxygen-rich atmosphere. The planet is alive, but only just. The greatest environmental change in Earth's history is still waiting to begin, and when it does, the air itself will be transformed forever.
As hundreds of millions of years quietly passed, Earth's ancient oceans became home to countless microscopic communities. Generation after generation lived, divided, and disappeared. Most changes were so small that no one could have noticed them. But nature did not need speed. It only needed time. And time was something our young planet had in abundance. Imagine floating just beneath the surface of one of these ancient seas. The water is warm, the waves move gently overhead. Sunlight filters down through the clear shallows, reaching rocks covered with thin layers of living microbes. To us, these organisms would appear insignificant, yet among them, one group is about to make perhaps the most important discovery in the history of life. Instead of feeding only on chemicals dissolved in the water, these remarkable microbes begin using something that had always surrounded them: sunlight. Every morning, the young sun rises above the horizon, flooding the oceans with energy. For hundreds of millions of years, that light had simply warmed the planet. Now, tiny organisms learn how to capture it. These ancient microbes, known today as cyanobacteria, develop an extraordinary process that modern scientists call photosynthesis. The idea sounds almost magical. Using nothing more than sunlight, water, and carbon dioxide, they begin creating their own food. It is one of the most efficient biological inventions ever to evolve. Even more remarkable is what they release as a byproduct: oxygen. At first, the amount is incredibly small. Each microscopic cell contributes only a tiny bubble. One bubble means almost nothing, but billions upon billions of microbes working together over millions of years can transform an entire planet.
The oxygen they produce does not immediately fill the atmosphere. Instead, it reacts with dissolved iron in the oceans. The iron rusts. Tiny particles sink slowly to the seafloor. Layer after layer accumulates, forming beautiful bands of red and dark rock that geologists still find today. These ancient formations are like pages in Earth's oldest history book. They silently record the moment when life first began changing the chemistry of the world. For an unimaginably long time, nearly every molecule of oxygen produced by cyanobacteria is absorbed by rocks, minerals, and seawater. The atmosphere barely changes. Life continues quietly. The stromatolites grow larger. New microbial colonies spread along coastlines and shallow seas. The Earth still looks empty from above. There are no forests to colour the land green, no birds flying through the sky, no fish leaping from the water. If a traveller from another world visited now, they might conclude that Earth was almost lifeless. They would be completely mistaken. The greatest transformation in planetary history is already underway. It is simply happening far too slowly for any single generation to notice. Millions of years become tens of millions become hundreds of millions. The patient work of cyanobacteria never stops. Every sunrise brings another opportunity to gather light. Every sunset ends another quiet day of invisible labour. Without realizing it, these tiny organisms are preparing the world for creatures that will not appear for billions of years, including us. It is astonishing to think that every breath you take today is connected to these ancient microbes. The oxygen filling your lungs is part of a cycle they helped begin over 2 billion years before humans ever existed. They could never have imagined forests or whales.
Or butterflies, or cities. Yet every one of those future wonders depends on the simple process they discovered. Still, change often brings unexpected consequences. While oxygen would one day become essential for complex life, it is actually poisonous to many of Earth's earliest organisms. Those ancient microbes had evolved in a world without oxygen. To them, this new gas is dangerous. As oxygen slowly accumulates, countless species begin disappearing. Some retreat deep beneath the ocean floor. Others survive in places where oxygen cannot easily reach. Even today, descendants of those ancient organisms still live in oxygen-free environments, such as deep sediments, swamps, and hydrothermal vents. Meanwhile, cyanobacteria continue spreading across the planet. Shallow seas become vast living carpets of microscopic life. The air changes so gradually that no single moment marks the beginning of a new world. Instead, Earth quietly crosses another invisible threshold. For the first time in its history, the atmosphere is beginning to fill with oxygen. No one is there to celebrate. No witness records the event. The only audience is the planet itself. The sky remains hazy. The oceans continue rolling beneath the wind. Volcanoes still reshape the land. Yet beneath this familiar appearance, Earth is becoming a completely different world. The stage is being prepared for an event that scientists now call the Great Oxygen Revolution. A transformation so dramatic that it will change the oceans, the atmosphere, the climate, and the future of every living creature. But before that revolution reaches its peak, our planet must first endure one of the greatest environmental upheavals it has ever experienced. That extraordinary chapter awaits us next, as oxygen slowly begins to reshape the face of the Earth forever.
As our peaceful journey continues, the Earth has now reached another quiet turning point. If you could look down upon the planet from space, it would still appear familiar. Dark oceans cover most of its surface. Scattered volcanic islands rise from the sea. Clouds drift slowly around the globe. At first glance, nothing seems very different. Yet, appearances can be wonderfully misleading. Hidden within those ancient oceans, trillions upon trillions of tiny cyanobacteria continue their silent work. Every sunrise, they welcome the light of the young sun. Every day, they transform water and carbon dioxide into food. And every evening, they release another invisible gift into the world: oxygen. For countless millions of years, that oxygen never remained in the atmosphere for long. It immediately reacted with iron dissolved throughout the oceans. The iron slowly rusted. Layer after layer settled onto the seafloor. Even today, miners around the world uncover these ancient banded iron formations, beautiful stripes of deep red and dark grey stone, created by microbes that lived more than 2 billion years ago. But Earth was slowly running out of dissolved iron. After hundreds of millions of years, most of it had already reacted with oxygen. The oceans could no longer absorb every new molecule being produced. For the very first time, oxygen began escaping into the atmosphere. At first, the increase was almost impossible to notice. The concentration remained tiny, far less than 1% of today's atmosphere. If you had somehow stood upon the shoreline, you would have seen no dramatic change. The waves still rolled gently onto dark volcanic beaches. Steam still rose from distant volcanoes.
The wind still carried the scent of sulfur and minerals. Nature rarely changes all at once. Instead, it whispers before it speaks. Year after year, century after century, million after million, the atmosphere slowly accumulated more oxygen. To many of Earth's oldest life forms, this invisible gas was not a blessing, it was a poison. For billions of years they had evolved in an oxygen-free world. Their cells were never designed to handle this new chemical. As oxygen spread, entire communities of ancient microbes began disappearing. Some became extinct forever. Others escaped into places where oxygen could not easily reach, deep underground, beneath thick ocean sediments, inside hydrothermal vents. Even today, descendants of those ancient organisms still survive in environments almost untouched by oxygen, quietly preserving a living memory of Earth's distant past. Meanwhile, the cyanobacteria continued flourishing. They did not know they were changing an entire planet. They simply lived one ordinary day after another, absorbing sunlight, growing, dividing, repeating the same simple cycle countless trillions of times. Sometimes the greatest revolutions begin without anyone noticing. As oxygen accumulated, another remarkable transformation quietly unfolded high above the Earth.
Powerful ultraviolet rays from the sun constantly struck oxygen molecules in the upper atmosphere. Some molecules split apart, others recombined into a new form, ozone. Little by little, an invisible shield began forming around the planet. This growing ozone layer absorbed much of the dangerous ultraviolet radiation that had once bombarded Earth's surface. Before its formation, sunlight carried deadly radiation capable of damaging fragile cells. Now, for the first time, parts of the planet became safer for life. No living creature celebrated this invisible achievement. No flowers bloomed, no birds sang, yet one of the greatest protective barriers in Earth's history had quietly appeared. Without it, complex life might never have been able to leave the oceans. Far below, the seas themselves also continued changing. Many regions that had once been rich in dissolved iron now became clearer. The chemistry of the water slowly shifted. New ecological opportunities appeared. Some microbes learned to tolerate oxygen. Others even discovered how to use it, and this changed everything. Oxygen allowed cells to release far more energy from food than older chemical processes ever could. Think of it as replacing a small candle with a bright lantern. The same amount of fuel now produced much more usable energy. Although the organisms remained microscopic, their future possibilities expanded enormously. Greater energy meant greater complexity could eventually evolve. The path towards larger cells, more advanced life, and eventually animals had quietly begun. Yet Earth was still far from the colourful world we know today. The continents remained mostly barren rock. No grass covered the hills, no trees shaded the valleys. Rain fell upon empty landscapes, shaped only by wind, rivers, volcanoes, and time. If you listened carefully, you would hear only waves breaking against ancient shores. No insects buzzed, no frogs called, no birds greeted the morning. The silence was almost complete. Still, beneath that silence, the planet was preparing for another extraordinary surprise. Because oxygen, while transforming the atmosphere, would also trigger dramatic changes in Earth's climate. Changes so severe that much of the entire planet might eventually become locked beneath ice. A frozen world unlike anything humanity has ever witnessed. And that remarkable story is where our journey will continue next.
The quiet work of cyanobacteria had now transformed the atmosphere more than anyone could have imagined. For hundreds of millions of years, oxygen continued to rise. Not quickly, not dramatically, but steadily. Every sunrise added another tiny contribution. Every generation of microbes released a little more of the invisible gas. Together, they were rewriting the chemistry of an entire world. Yet every great change comes with unexpected consequences. Long before oxygen became the foundation of complex life, it quietly began altering Earth's climate. To understand why, imagine the atmosphere as a giant blanket wrapped around the planet. Some gases trap heat, others allow it to escape into space. In Earth's early history, one of the most important heat-trapping gases was methane. Produced by ancient microorganisms, methane helped keep the young Earth warm beneath a fainter sun. Without it, the oceans might have frozen long before life had a chance to grow. But oxygen and methane do not peacefully coexist. When they meet, they react. Little by little, oxygen destroyed enormous amounts of atmospheric methane. The thick warming blanket around the planet slowly became thinner. As methane disappeared, Earth's temperature began to fall. At first, the cooling was gentle. A few regions became colder, winter-like conditions lingered a little longer. Ice began forming in places where it had rarely appeared before. Then the cooling accelerated. Bright white ice reflected more sunlight back into space than dark oceans ever could. The more ice formed, the more sunlight was reflected away, and the less heat the Earth retained.
This created a powerful cycle. More ice meant lower temperatures. Lower temperatures created even more ice. Nature had entered a feedback loop. Over millions of years, glaciers expanded farther and farther from the poles. They crept across ancient coastlines. Frozen seas stretched towards the equator. Mountain ranges disappeared beneath thick blankets of ice. Entire continents turned white. Some scientists believe that during this extraordinary period, our planet may have become almost completely frozen. This remarkable chapter in Earth's history is often called Snowball Earth. Imagine looking down from space. Instead of deep blue oceans and green continents, you would see an almost entirely white world. Ice stretches across thousands of kilometers. The oceans are covered by thick, frozen layers. Clouds drift over an endless landscape of snow and ice. Only scattered volcanoes break the frozen silence, their glowing lava standing in dramatic contrast against the brilliant white surroundings. It is one of the most astonishing landscapes Earth has ever known. If you somehow stood upon this frozen world, the silence would feel almost overwhelming. The wind would sweep across endless plains of ice. No forests would sway, no birds would fill the sky, no animals would leave footprints in the snow. The planet would appear completely abandoned. Yet appearances once again would be deceiving. Life had not disappeared, it had simply retreated. Deep beneath the ice-covered oceans, hydrothermal vents continued pouring warm, mineral-rich water into the darkness.
Around these underwater oases, countless microscopic organisms survived. Some endured beneath thin patches of open water near volcanic regions. Others remained hidden within the oceans themselves, protected beneath kilometers of ice. Life had become incredibly resilient. It had learned one of its greatest lessons. Survival does not always belong to the strongest. Sometimes it belongs to those who can patiently endure change. Millions of years passed across this frozen Earth. The sun continued rising every day. The moon still pulled the tides beneath the thick ice. Deep inside the planet, volcanoes never stopped erupting. Each eruption released carbon dioxide into the atmosphere. Normally, rain would wash much of that carbon dioxide into the oceans, but with the surface frozen, that natural process slowed dramatically. Year after year, century after century, million after million, carbon dioxide slowly accumulated in the atmosphere. Like an ever-thickening blanket, it trapped increasing amounts of heat. The frozen planet began warming once again. At first, almost nothing changed. Then tiny cracks appeared within the ice. Small patches of dark ocean emerged. Those dark waters absorbed far more sunlight than the brilliant white ice surrounding them. The warming accelerated. The cracks widened. Glaciers retreated. Ancient rivers flowed once more. Eventually, the great ice sheets collapsed, releasing vast oceans that had remained imprisoned for millions of years. The transformation was breathtaking. Earth had survived one of the most extreme climate events in its entire history, and life had survived with it. The world emerging from the ice was very different from the one that had entered it. The atmosphere now contained far more oxygen than before. The oceans were changing. New ecological opportunities appeared everywhere. The long, quiet age of microscopic life was slowly approaching its end. Something extraordinary was waiting just beyond the horizon of time. Within the oceans, new forms of life would soon begin experimenting with larger bodies, specialized cells, and entirely new ways of living. The seas, once inhabited only by invisible microbes, would soon become home to strange and wonderful creatures, unlike anything the Earth had ever seen. And that is exactly where our journey will continue in the next chapter, the mysterious age of Earth's first extraordinary ocean animals.
As the great ice slowly released its grip on the planet, Earth seemed to take a long, gentle breath. The frozen oceans began flowing once more. Ancient rivers returned to life. Clouds gathered above open water. Rain once again fell upon the rocky continents. For millions of years, the world had endured unimaginable cold. Now, warmth was slowly returning. The atmosphere contained more oxygen than ever before.
The oceans were rich with nutrients carried by melting glaciers and ancient rivers. Sunlight reached wide stretches of open sea. The stage was finally set for one of the most remarkable chapters in the history of life. For billions of years, Earth had belonged almost entirely to microscopic organisms. Tiny cells had patiently shaped the atmosphere, survived global ice ages, and quietly transformed the chemistry of the oceans. But now, something extraordinary was about to happen. Life would begin experimenting with size. Imagine drifting peacefully beneath the surface of an ancient sea nearly 600 million years ago. The water is calm. Soft beams of sunlight dance through the gentle waves above. The ocean floor stretches into the distance, covered with fine sediments and strange, soft shapes, unlike anything alive today. There are still no fish, no sharks, no dolphins, no whales. The oceans remain strangely silent, yet they are no longer empty. Scattered across the seabed lie mysterious living forms. Some resemble delicate leaves resting flat against the sand. Others look like quilted cushions, gently swaying with the current. A few appear almost like feathers growing directly from the ocean floor. These unusual organisms belong to one of Earth's earliest communities of large multicellular life. Today, scientists call many of them the Ediacaran biota. They remain among the greatest mysteries in paleontology. Some may have been early animals. Others might represent entirely different branches of life that disappeared forever. No one knows with complete certainty. That uncertainty makes them even more fascinating. Unlike modern creatures, many have no mouths,
No eyes, no shells, no bones. Their soft bodies leave only faint impressions within ancient rocks. If you could gently touch one, it might feel more like a soft mattress than a living animal. The ocean floor during this time is peaceful. These creatures do not chase prey. They do not flee from predators. Many simply absorb nutrients directly from the surrounding water or from microscopic organisms living nearby. It is a quiet world, a slow world, one where life seems content simply to exist. For millions of years, these strange beings flourish across the shallow seas. Generation follows generation. The continents continue drifting. Volcanoes reshape distant coastlines. The moon slowly moves further away from Earth. The days themselves become slightly longer. Tiny changes accumulate across vast stretches of time. Then, almost as suddenly as they appeared in the fossil record, many of the Ediacaran organisms vanish. Scientists still debate exactly why. Perhaps changing environments made survival more difficult. Perhaps new kinds of animals evolved and outcompeted them. Or perhaps predators had finally arrived. Whatever the reason, Earth was preparing for another dramatic leap forward. Roughly 541 million years ago, something extraordinary happened. In a relatively short geological period, life diversified at an astonishing pace. Scientists call this event the Cambrian explosion.
It was not an explosion in the ordinary sense. No single day transformed the oceans. Instead, over several tens of millions of years, evolution accelerated in remarkable ways. New body designs appeared, hard shells evolved, protective armor became common, jointed limbs emerged, eyes capable of detecting light developed for the very first time. The ancient seas, once calm and peaceful, suddenly became much more active. For the first time, some creatures began hunting others. Predators appeared, prey developed defenses, a great evolutionary race had begun. Imagine swimming through these Cambrian seas. The ocean floor is alive with movement. Tiny trilobites crawl across the sediments like armored insects. Worm-like creatures burrow beneath the sand. Sponges filter water quietly. Strange jelly-like animals drift through gentle currents. Everywhere you look, life is experimenting. Some designs will succeed for hundreds of millions of years, others will disappear almost as quickly as they arrived. Nature is trying every possibility. It is a time of endless invention. No engineer could have planned so many extraordinary forms. No artist could easily imagine such bizarre creatures. And yet, every one of them is completely real.
This ancient ocean has become Earth's greatest laboratory once again, only now the experiments are visible to the naked eye. The age of large complex life has truly begun. But among all these remarkable animals, one predator stands apart from the rest, a creature unlike anything that had ever lived before. With enormous eyes, grasping limbs, and terrifying speed, it would become the undisputed hunter of the Cambrian seas. And in the next part of our journey, we will come face to face with one of Earth's first great predators and witness how competition forever changed the story of life.
As the Cambrian seas continued to flourish, life became more adventurous than ever before. For billions of years, survival had been relatively simple. Most organisms drifted with the currents. Others remained attached to rocks on the ocean floor. There was little need to chase, little need to hide. But that peaceful world was slowly disappearing. Evolution had discovered something entirely new: predators. And wherever predators appeared, prey had to become smarter, faster, or better protected. This single change would shape the future of life for hundreds of millions of years. Imagine yourself drifting through a warm Cambrian sea nearly 520 million years ago. Sunlight reaches deep into the clear blue water. Below, the seafloor is covered with countless strange creatures. Some slowly crawl across the sand, others wave delicate feeding arms into the current. Tiny trilobites move in long lines, searching for food among the sediments. Every direction reveals forms unlike anything found in today's oceans. The sea is no longer silent, it is alive with movement. One of the most familiar animals of this age is the trilobite. These remarkable creatures wear hard segmented shells that protect their soft bodies. Some are no larger than a fingernail, others grow to the size of a dinner plate. With dozens of tiny legs hidden beneath their armored bodies, they carefully explore the ocean floor. When danger approaches, many curl themselves into tight protective balls, much like modern pillbugs. For nearly 270 million years, trilobites will thrive in Earth's oceans, becoming one of the longest-lasting groups of animals in history. Nearby, strange worm-like creatures dig tunnels beneath the sand. Primitive mollusks slowly glide across rocks. Early relatives of starfish and sea urchins begin appearing. Sponges continue filtering enormous volumes of seawater each day. Every species fills a different role. Together, they create the planet's first truly complex ecosystems. Yet among this incredible diversity, one animal commands attention above all others. Its name is Anomalocaris. To modern eyes, it looks almost like a creature from science fiction. Its body stretches nearly a meter in length, making it enormous compared to most other Cambrian animals. Large compound eyes give it exceptional vision.
Two long, spiny, grasping appendages extend from the front of its head. A circular mouth lined with hard plates sits beneath its body. Flexible fins ripple along its sides, allowing it to glide gracefully through the water. For its time, it is the undisputed giant of the sea. Imagine watching this remarkable hunter move through the ancient ocean. It does not rush wildly. Instead, it swims with quiet confidence. Its enormous eyes constantly scan the surroundings. Tiny movements betray the presence of hidden prey. With astonishing speed, its grasping limbs reach forward. A trilobite attempts to escape across the seafloor. For a brief moment, predator and prey race through one of Earth's very first underwater hunts. Sometimes the trilobite escapes. Its armor proves strong enough. Other times, Anomalocaris succeeds. Nature is beginning to test new strategies. Better eyesight, greater speed, protective shells, improved senses. Each innovation encourages another. The struggle for survival becomes one of evolution's greatest teachers. It is during this period that many of the basic body plans seen in modern animals first appear. Early ancestors of insects, crustaceans, worms, mollusks, and even vertebrates begin their long evolutionary journeys. One tiny fish-like creature known as Picaia swims gently through the Cambrian waters. At first glance, it seems completely ordinary. It is slender, soft-bodied, barely a few centimeters long, yet hidden inside its body is a flexible supporting rod called a notochord. This simple structure may seem insignificant, but it represents one of the most important innovations in the history of life. From creatures similar to Picaia, an extraordinary family tree will eventually emerge: fish, amphibians, reptiles, birds, mammals. And after hundreds of millions of years, human beings. It is astonishing to realize that our own distant ancestors were once tiny swimmers in these ancient seas. If you looked carefully, you would never guess that such humble creatures would one day build cities, write books, explore space, or wonder about their own origins. Nature rarely reveals its future. It simply continues one small step at a time. As millions of years quietly pass, the Cambrian explosion gradually settles into a new balance. The oceans are now filled with complex ecosystems. Predators hunt, prey adapts, new species appear, while others quietly disappear. Life has become wonderfully diverse, yet the greatest adventures are still ahead. Soon, some courageous organisms will leave the safety of the oceans behind. They will crawl onto barren rocks where no life has ever existed before. The continents, silent for billions of years, are about to welcome their very first living visitors. And with that bold step, Earth will begin another unforgettable chapter, one that will eventually lead to vast forests, giant insects, towering reptiles, and a world unlike anything the oceans alone could ever create.
Our story now moves forward through another vast stretch of time. The ancient oceans continue to flourish with extraordinary life. Fish become more diverse. Plants slowly spread across the land. The first forests appear, covering once barren continents with endless shades of green. Gigantic insects buzz through warm, humid air. Amphibians thrive beside rivers and swamps. Eventually, reptiles evolve, animals better suited for life away from water. For millions upon millions of years, Earth changes almost beyond recognition. Then, about 252 million years ago, something terrible happens. The planet experiences the greatest mass extinction in its entire history. Scientists call it the Permian-Triassic extinction. Nearly 90% of marine species and around 70% of land vertebrate species disappear. Massive volcanic eruptions in what is now Siberia release enormous amounts of carbon dioxide and other gases, driving severe climate change, ocean warming, and widespread ecological collapse. The Earth becomes a quieter place. Ancient forests vanish. Countless species that had ruled the world for millions of years simply disappear. If someone had walked across the continents then, they would have found a landscape strangely empty. But throughout Earth's history, endings often become beginnings. From the survivors of this catastrophe, new groups of reptiles begin to flourish. At first they are small. Most are no larger than modern dogs. They live alongside many other strange reptiles, competing for food and shelter. Nothing about them suggests they will one day dominate the entire planet. Yet, evolution is patient. Tiny advantages accumulate over millions of years. Some of these reptiles stand more upright than their relatives. Their legs are positioned beneath their bodies instead of sprawling outward. This allows them to move more efficiently. Some breathe more effectively. Others grow faster. Generation after generation, these advantages slowly spread. Around 230 million years ago, the first true dinosaurs appear. They are not giants, far from it. Many are lightly built and surprisingly small. Imagine standing quietly in a warm Triassic forest. Tall conifer trees stretch toward the sky. Ferns blanket the forest floor. Small reptiles dart between fallen branches. In the distance, a slender dinosaur, no taller than your waist, cautiously steps from the shadows. It pauses. Its sharp eyes scan the surroundings. Its long tail helps balance its body. Then, with graceful speed, it disappears among the trees. This is no terrifying monster. It is simply another survivor trying to make its way through an ever-changing world. The climate during the Triassic is very different from today. Most of Earth's continents are joined together into one enormous supercontinent called Pangaea.
Imagine a single landmass stretching almost from one pole to the other. Instead of crossing oceans between continents, an adventurous traveller could walk across immense landscapes that today lie thousands of kilometres apart. The interior of Pangaea is often dry. Great deserts stretch toward the horizon. Seasonal rains nourish scattered forests and rivers. Along the coasts, the climate is generally milder, supporting a growing diversity of plants and animals. As millions of years pass, dinosaurs slowly become more successful. Some remain small and swift, others grow larger. New species evolve to fill different ecological roles. Some feed on insects, others hunt small reptiles. A few begin eating tough leaves from ancient trees. Nature continues experimenting. One branch after another appears. Some vanish, others flourish. The Earth itself remains restless. Deep beneath the surface, tectonic forces slowly begin pulling Pangaea apart. Tiny cracks appear within the enormous continent. At first they seem insignificant, but over millions of years, those cracks widen into valleys. Valleys become seas. Eventually, they will become the great oceans that separate today's continents. The world is quietly reshaping itself beneath the feet of its newest rulers. Still, dinosaurs have not yet reached their greatest age. That glorious chapter is only beginning. Soon the climate will become warmer, the continents will drift farther apart, lush forests will spread across much of the globe, and dinosaurs, both gentle giants and fearsome hunters, will grow into some of the largest animals ever to walk upon the earth. In the next part of our journey, we will enter the golden age of the dinosaurs, when these extraordinary creatures ruled the land for more than 160 million years, beneath skies also filled with remarkable flying reptiles, and alongside oceans patrolled by giant marine predators.
As the ages quietly passed, the descendants of those early dinosaurs spread across the great supercontinent of Pangaea. Then, almost imperceptibly, the world itself began to change once again. The enormous continent slowly cracked apart. The movement was so gentle that no creature could possibly notice it within a lifetime. Yet over millions of years, the cracks widened into valleys. The valleys filled with water. New oceans slowly emerged. The continents that we recognize today had begun their long journey across the face of the earth. This gradual separation changed everything. Fresh coastlines appeared. Mountain ranges slowly rose. Rainfall patterns shifted. New forests spread across the land. As environments became more diverse, so did life itself. The climate during much of the Jurassic period was warm and humid. There were no polar ice caps like those of our modern world. Dense forests of conifers, cycads, tree ferns, and ginkgo trees covered vast stretches of land. If you wandered through one of these ancient forests, the air would feel heavy with moisture. Soft sunlight filtered through towering trees. Gentle streams wound quietly between enormous trunks. At first, the landscape might seem peaceful. Then the ground beneath your feet would begin to tremble. Slowly, rhythmically, a distant herd approaches. Out from the forest emerge some of the largest land animals ever to exist. Towering sauropods.
Imagine creatures taller than a 4-story building. Their necks stretch gracefully toward the treetops. Their long tails sweep behind them like enormous living bridges. Each slow step shakes the ground beneath them. Yet despite their incredible size, most are peaceful plant eaters. For hour after hour, they browse on leaves high above the reach of smaller animals. They travel together in family groups, protecting younger members in the center of the herd. A single adult may consume hundreds of kilograms of vegetation each day. The forests seem endless. Even so, these gentle giants spend much of their lives searching for enough food. Nearby, another group of dinosaurs follows a very different path. These are the great predators. Among them is one of the most famous hunters in Earth's history, Allosaurus. Unlike the peaceful sauropods, Allosaurus survives by hunting. It moves with surprising agility for such a large animal. Powerful legs carry it swiftly through the forest. Sharp claws grip the ground. Rows of serrated teeth wait behind powerful jaws. Yet hunting is never easy. Most attempts fail. Prey escapes, opportunities are missed. Like modern lions or wolves, these predators must conserve their energy carefully. Every successful hunt may need to sustain them for many days. While dinosaurs dominate the land, the skies tell another remarkable story. High above the forests soar the pterosaurs,
Although many people mistakenly call them flying dinosaurs, they belong to a separate group of reptiles.
Some are no larger than modern pigeons. Others possess wingspans wider than a small airplane. They ride warm air currents effortlessly above rivers, coastlines, and ancient seas. Below them, another hidden world flourishes. The oceans are filled with magnificent marine reptiles. Long-necked plesiosaurs glide silently through coastal waters. Swift ichthyosaurs, shaped somewhat like modern dolphins, pursue schools of fish. Later, gigantic mosasaurs become among the ocean's most formidable predators. It is important to remember that these magnificent marine reptiles are not dinosaurs either. They evolved along different evolutionary paths. Yet together, they help make the Mesozoic one of the richest periods of life our planet has ever known. As millions of years quietly pass, evolution continues its patient work. Some small dinosaurs develop increasingly complex feathers. At first, these feathers likely help with warmth or display. Only later do they assist with gliding and flight. One remarkable creature, Archaeopteryx, appears around 150 million years ago. It possesses both reptilian and bird-like features: feathered wings, sharp teeth, a long bony tail, clawed fingers. It represents one of the most fascinating transitional animals ever discovered. From small feathered dinosaurs like these, the birds that fill our skies today will eventually evolve. Listen carefully to the Jurassic forest. There are no songs like those of modern robins or sparrows. Instead, the sounds are unfamiliar. The deep calls of giant herbivores echo through the trees. Predators announce their presence with powerful roars. Insects buzz through the humid air. Streams quietly flow over ancient stones. It is a world both beautiful and strange. For more than 160 million years, dinosaurs flourish across nearly every continent. Generation after generation lives beneath changing skies. Mountains rise, seas advance and retreat. Flowers eventually begin to appear, adding new colors to the landscape. Life seems wonderfully abundant. If you had lived during this age, you might have believed that the dinosaurs would rule forever. Nothing appears capable of challenging their dominance. But the universe often reminds us that even the longest chapters eventually come to an end. Far beyond the Earth, deep within the darkness of space, a mountain-sized asteroid is quietly following its ancient orbit around the Sun. For millions of years it travels unnoticed. Its path seems ordinary. Its journey appears peaceful. Yet with every passing century, it draws a little closer to our planet. The age of dinosaurs is approaching its final sunrise, and in the next chapter, we will witness the single day that forever changed the history of life on Earth. For more than 160 million years, the dinosaurs had ruled the Earth. Generation after generation was born beneath warm skies. Forests stretched across the continents. Flowering plants spread through valleys and riverbanks. Small mammals lived quietly in the shadows, rarely attracting much attention. Birds, descendants of feathered dinosaurs, filled parts of the sky. Life seemed stable, permanent, as if this magnificent age would continue forever. But the universe has never promised permanence. Far beyond the orbit of Mars, countless rocky bodies circle the Sun. Most remain harmless. Some occasionally cross the paths of planets. One of those ancient travelers had been drifting through space for millions of years. It was roughly 10 to 12 kilometers across, dark, silent, unaware that it was moving toward one of the most important moments in Earth's history. Its journey had begun long before humans, mammals, or even dinosaurs existed. For countless ages, gravity gently altered its path. A slight pull from one planet, another small nudge from a different orbit. Tiny changes accumulated over millions of years. Eventually, its course intersected with Earth's. No living creature noticed. No dinosaur looked toward the heavens with fear. The asteroid remained only another distant object among countless stars. As the final hours approached, Earth continued as it always had. Morning sunlight warmed the forests. Herds of giant herbivores wandered across broad floodplains. Predators searched patiently through the trees. Small mammals gathered seeds and insects beneath fallen logs. Pterosaurs drifted over quiet coastlines. Marine reptiles hunted in warm, shallow seas. Everything felt wonderfully ordinary. Then,
The asteroid entered Earth's atmosphere. Within seconds, friction with the air heated its surface to extraordinary temperatures. The sky blazed brighter than the sun. Across thousands of kilometers, animals instinctively looked upward. A brilliant streak of fire raced across the heavens. For many creatures, it was the last sunrise they would ever see. Traveling at nearly 20 kilometers per second, the asteroid struck what is now the Yucatan Peninsula. The impact lasted only a few moments, yet those moments changed the future of life forever. The collision released an amount of energy equal to billions of nuclear explosions. The ground itself seemed to disappear beneath unimaginable force. Solid rock instantly vaporized. A gigantic crater nearly 180 kilometers wide began forming. Today, scientists know it as the Chicxulub crater. Everything within hundreds of kilometers vanished almost instantly. Mountains collapsed, forests disappeared. Entire ecosystems ceased to exist in the blink of an eye. A tremendous fireball expanded outward from the impact site. Its heat ignited vegetation across vast regions. Shockwaves raced through the atmosphere faster than sound. Earthquakes far stronger than any recorded by humans shook the planet. Across distant oceans, enormous tsunamis rose hundreds of meters high. Walls of water crashed against ancient coastlines. Sediments were stripped away. Marine habitats were devastated. Yet these immediate disasters were only the beginning. The impact hurled trillions of tons of dust, ash, sulfur-rich rock and tiny molten fragments high into the atmosphere.
Some material escaped into space before falling back toward Earth. As these glowing fragments re-entered the atmosphere, they heated the air across much of the planet. For a time, the skies themselves seemed to burn. Wildfires spread across enormous areas. Smoke joined the dust already filling the atmosphere. Soon, sunlight could no longer reach the surface. Day gradually faded into a strange twilight, then into darkness. Not the familiar darkness of night, but a darkness that lingered. The sun still shone beyond the thick clouds of dust, yet its light struggled to reach the ground. Temperatures began falling. Plants, deprived of sunlight, could no longer produce enough energy. Leaves withered. Forests stopped growing. The great food chains that had supported dinosaurs for millions of years slowly began collapsing. Large herbivores found less and less to eat. Predators soon discovered that prey had become increasingly scarce. The mighty rulers of the earth were not defeated in a single day. Their worlds simply became impossible to survive within. One by one, season after season, species that had flourished for millions of years quietly disappeared. The silence spreading across the continents must have been unlike anything our planet had experienced before. Yet hidden beneath the fallen leaves, inside deep burrows, within sheltered rivers and quiet forests, a few small survivors endured. Tiny mammals, small birds, crocodilians, turtles, frogs, and countless insects. Their time had not yet come, but it soon would, because the end of the dinosaurs was not the end of life. It was the beginning of an entirely new chapter. And in the next part of our journey, we will witness how a world that seemed utterly destroyed slowly healed itself, and how small, humble mammals began the long path toward eventually becoming the dominant animals on Earth.
The impact hurled trillions of tons of dust, ash, sulfur-rich rock, and tiny molten fragments high into the atmosphere. Some of the debris escaped beyond the edge of Earth's atmosphere before gravity slowly pulled it back again. As countless glowing fragments re-entered the sky, they heated the air across much of the planet. For a brief time, the heavens themselves appeared to burn. Tiny pieces of molten rock rained down across continents and oceans alike. Dry forests ignited, grasslands caught fire, smoke rose into an already darkening sky. Within days, a thick blanket of dust and soot surrounded the earth. Sunlight struggled to pass through it. Morning no longer looked like morning, afternoon resembled twilight. Then, even at midday, much of the world lay beneath an eerie darkness. Imagine standing on the shore of an ancient sea. The waves still roll gently toward the land, the wind still blows across the water, but the warm sunlight that had nourished life for millions of years has vanished. The sky is grey, the air is cold. Silence spreads across forests that had once echoed with the footsteps of giant dinosaurs. Plants are the first to suffer. Without sunlight, photosynthesis nearly comes to a halt. Leaves wither, ferns stop growing, flowering plants produce fewer seeds. Across the continents, vast forests begin dying. As the plants disappear, so does the food that countless herbivores depend upon. The enormous sauropods struggle to find enough leaves. Duck-billed dinosaurs wander further each day in search of fresh vegetation.
Horned dinosaurs grow weaker with every passing week. Predators face an equally desperate future. Without healthy herds to hunt, even the greatest carnivores begin starving. The mighty hunters that had ruled the earth for millions of years cannot outrun hunger. One by one, ancient ecosystems begin collapsing. The oceans suffer as well. Tiny plankton floating near the surface depend upon sunlight just as plants do. As they disappear, creatures that feed upon them begin declining. Then the predators that depend upon those animals also begin disappearing. Like falling dominoes, entire food webs collapse from the smallest organisms to the largest hunters. Weeks become months. Months become years. The Earth grows colder. Scientists believe global temperatures drop dramatically after the impact. Some regions may have experienced freezing conditions that had not existed there for millions of years. Rain mixed with sulfur released from the impact, making parts of the world more acidic. Lakes and rivers changed. Coastal ecosystems struggled to recover. It was not a single day that ended the age of dinosaurs. It was a chain of events. Darkness, cold, starvation, collapse. Generation after generation simply failed to survive. By the time sunlight finally began reaching the surface again, the world had changed forever. Nearly 75% of all species on Earth had disappeared. The giant non-avian dinosaurs were gone.
The flying pterosaurs vanished. Many marine reptiles that had ruled the oceans also disappeared forever. It seemed almost impossible that life could recover from such devastation. Yet Earth had survived enormous challenges before. It had endured global ice ages, massive volcanic eruptions, changing oceans, a poisonous atmosphere. Each time, life had quietly found a way forward. This time would be no different. Beneath fallen trees, tiny mammals remained hidden inside warm burrows. Some survived by eating seeds, others fed on insects. Many required only small amounts of food compared with the giant reptiles that had dominated the land. Freshwater turtles rested safely beneath muddy riverbeds. Crocodilians waited patiently in quiet wetlands. Small birds, descendants of feathered dinosaurs, continued searching for whatever food they could find. They were not the strongest animals on Earth. They were simply the most adaptable. Nature often rewards flexibility more than size. As centuries slowly passed, green shoots began pushing through the blackened soil. Young forests appeared where ancient ones had vanished. Rivers once again reflected blue skies. The air gradually became clearer. The world was healing. No dinosaur remained to witness the recovery. Their chapter had come to its peaceful end. But hidden among the survivors was a group of small, warm-blooded animals that had waited patiently in the shadows for more than 100 million years. Their age was finally about to begin. And with their rise, the long journey toward humanity would quietly take its first remarkable steps.
The giant non-avian dinosaurs were gone. The mighty pterosaurs no longer soared above ancient coastlines. The great marine reptiles that had dominated the oceans for millions of years also vanished forever. The world that had once belonged to giants had become strangely quiet. If you could have walked across the earth at this moment, you would have found a landscape unlike anything before it. Towering forests had been reduced to blackened trunks. Ash covered the ground like dark snow. Many rivers carried fallen branches towards silent seas. The familiar sounds of the Mesozoic had disappeared. No thunderous footsteps echoed through the forests, no giant predators called across the valleys. Only the gentle whisper of the wind moved through the recovering world. Yet beneath this silence, life had not surrendered. Hidden underground, tiny mammals waited patiently inside their burrows. Unlike the giant dinosaurs, they required very little food. Some survived by eating seeds buried beneath the ash. Others searched for insects hiding under fallen logs. A few fed on roots and fungi growing in the damp soil. They were small, unremarkable, easy to overlook.
But sometimes history belongs to those who simply endure. Freshwater rivers became important places of refuge. Turtles rested beneath muddy bottoms. Crocodilians drifted quietly through calm waters. Many amphibians survived because their lives depended less on forests and more on lakes and streams. Insects, too, slowly returned. They laid eggs, new generations emerged. Tiny ecosystems quietly began rebuilding themselves. The Earth had entered a long period of recovery. It would not happen in years, nor even in centuries. The healing of an entire planet would require millions of years. Slowly, sunlight began breaking through the dusty atmosphere once again. The skies grew brighter, temperatures gradually became warmer. The first green shoots pushed through the ash-covered ground. Ferns were among the earliest plants to reclaim the devastated landscapes. Where blackened forests had once stood, carpets of fresh green slowly spread across the continents. Soon, young trees followed. Ancient rivers flowed beneath growing forests once again. The scars of the impact remained, but nature continued doing what it had always done, beginning again, one generation at a time. As the forests returned, so did opportunity. The small mammals that had once lived quietly beneath the feet of dinosaurs suddenly found a world filled with empty habitats. There were no giant herbivores browsing the forests, few large predators remained. For the first time in over 160 million years, mammals were no longer living in the shadows. Some climbed into the trees, others adapted to life on open plains. Some became skilled hunters, others specialized in eating fruits, seeds, or insects. With every passing million years, mammals grew more diverse. They developed sharper senses, larger brains, more complex social behavior. Warm blood allowed them to remain active even when temperatures changed. Soft fur protected them from cold nights. Parents cared for their young with remarkable devotion. These qualities would eventually help mammals spread across nearly every environment on Earth. Still, if you had visited the planet then, you would never have guessed what lay ahead. No creature resembled a human. No cities existed. No tools had been crafted. The future remained hidden. Nature was simply taking its next quiet step. High above, the moon continued its slow journey away from Earth. The continents drifted a few centimeters every year. Mountains slowly rose while others gradually wore away. Everything changed, but always with extraordinary patience. The asteroid had ended one magnificent chapter, yet it had also opened another. The age of dinosaurs had come to a close. Now, without celebration or announcement, the age of mammals had quietly begun. And in our next chapter, we will follow these small survivors as they spread across the recovering world, eventually giving rise to giant mammals, strange new predators, and the distant ancestors of humankind.
As the dust from the great asteroid impact slowly settled, the Earth entered a quieter chapter. The age of giant reptiles had come to an end. In its place, a new world was beginning to emerge. The forests that had once echoed with the footsteps of dinosaurs were slowly turning green again. Fresh ferns spread across the ash-covered ground. Young trees reached toward the sunlight. Rivers flowed through peaceful valleys, carrying nutrients into lakes and seas. The planet had survived one of the greatest disasters in its history. Now, life was ready to begin again. The survivors of the catastrophe were not the largest animals, they were the smallest. Tiny mammals, many no larger than a modern mouse, quietly stepped into a world filled with opportunity. For more than 100 million years, these little creatures had lived in the shadows. While dinosaurs ruled the land, mammals remained hidden. Most were active at night. They sheltered in burrows or beneath dense vegetation. They survived by eating insects, seeds, fruits, and anything else they could find. Their lives had always been cautious. Now, for the first time, they could explore without giant dinosaurs towering above them. Imagine walking through one of these recovering forests about 65 million years ago. The air is fresh after a gentle morning rain. Young trees sway softly in the breeze. Birds call from the branches above. Small mammals dart through the undergrowth, searching for food. Some climb trees with remarkable agility.
Others dig tunnels beneath the forest floor. Everywhere you look, life is returning. At first, these mammals remain small, but evolution never stops. Generation after generation, they begin filling the empty roles left behind by extinct reptiles. Some become larger plant eaters, others develop into swift predators. Some adapt to rivers and wetlands, others move into open woodlands. The Earth is once again becoming wonderfully diverse. One of the greatest advantages mammals possess is their ability to care for their young. Unlike most reptiles, mammal mothers feed their babies with milk. They protect them, teach them, remain close until they are strong enough to survive on their own. This extra care greatly increases the chances of survival. Over millions of years, it becomes one of the defining strengths of the mammalian world. Another remarkable advantage lies hidden inside their skulls. Compared with many earlier animals, mammals develop increasingly complex brains. They learn quickly, remember important locations, recognize danger, adapt to changing environments. These abilities become especially valuable as Earth's climate continues evolving. The continents are no longer joined together. They drift slowly towards the positions we recognize today. The Atlantic Ocean grows wider each year. Mountain ranges such as the early ancestors of the Himalayas begin rising as enormous tectonic plates collide. New climates appear across different parts of the world.
Some regions become warm tropical forests, others develop into dry grasslands, still others remain cool and temperate. Each environment creates fresh opportunities for evolution. As millions of years quietly pass, mammals become astonishingly varied. Tiny bats take to the skies, becoming the only mammals capable of true powered flight. Early whales, whose distant ancestors once walked on land, gradually return to the sea. Over countless generations, their legs shrink, their bodies become streamlined, their nostrils slowly move towards the tops of their heads, eventually becoming blowholes. It is one of evolution's most extraordinary journeys. Back on land, hoofed mammals begin roaming open plains. Ancient relatives of horses, elephants, rhinoceroses, and deer appear. Many are still quite different from the animals we know today, but the foundations have been laid. Nature continues experimenting, just as it always has. Predators evolve alongside their prey. Some resemble enormous wolves, others look more like giant cats. Powerful birds without the ability to fly become dominant hunters in certain regions, proving that evolution often follows unexpected paths. The Earth is changing once more. The forests are richer, the skies are filled with birds, the oceans teem with whales, sharks, and countless fish. Life has recovered beyond anything that would have seemed possible after the asteroid impact. Yet the climate itself is preparing another great challenge. The world will gradually cool, vast grasslands will spread across continents, powerful glaciers will one day return, and among the trees of Africa, a small group of curious primates will begin a journey that eventually leads to every human being alive today. That remarkable story awaits us in the next part of our peaceful journey.
As millions of years quietly passed, the age of mammals continued to unfold. The forests became denser, the rivers carved deeper valleys, mountain ranges slowly climbed towards the sky as enormous tectonic plates continued their patient journey across the Earth. From one generation to the next, mammals spread into nearly every corner of the planet. Some remained tiny enough to fit in the palm of your hand, others grew into giants. Imagine standing on a peaceful grassy plain about 40 million years ago. The morning sun shines through a light mist. Gentle breezes ripple across endless fields. In the distance, herds of early horses quietly graze. They are much smaller than the horses we know today. Each has several toes instead of a single hoof. Nearby, ancient relatives of rhinoceroses wander through scattered woodlands.
Some elephant ancestors, still quite unlike modern elephants, slowly browse on leaves beside calm rivers. The world feels peaceful. Yet evolution never rests. Every generation carries tiny changes. A slightly longer leg, a stronger jaw, sharper eyesight, a more efficient way to digest food. Each improvement may seem insignificant.
They have forward-facing eyes that help them judge distance. Flexible hands allow them to grip branches securely. Their growing brains help them remember food sources and recognize danger. Most spend their entire lives in the trees. Few could imagine that some of their distant descendants would one day walk across continents. Far above, the climate continues cooling. The Earth is entering another gradual transformation. The poles become colder. Seasonal changes grow more noticeable. Snow remains on mountain peaks for longer periods each year. The planet is slowly preparing for an age of ice. At first, almost nobody would notice. A slightly colder winter, a little more snow, glaciers growing almost invisibly across distant mountains. But as always, Earth's greatest changes happen patiently. Century after century, million after million years. The cooling continues. The coming ice age will reshape rivers, carve valleys, lower sea levels, and challenge every living creature on the planet. For many animals, survival will become the greatest test they have ever faced. Yet among the forests of Africa, one small group of primates will discover an entirely new way of moving through the world. Instead of spending every moment in the trees, they will begin standing upright. Those first uncertain steps will eventually lead to the appearance of our own ancestors. And that remarkable journey begins in the next chapter, as the Ice Age quietly approaches, and the first humans prepare to enter Earth's extraordinary story.
As our journey continues, the Earth begins to feel different once again. The warm world that had allowed forests to stretch across much of the planet is slowly fading. The change does not happen in a single year, nor in a single century. Instead, it unfolds so gradually that no living creature can truly witness it from beginning to end. The continents continue drifting. Towering mountain ranges, including the young Himalayas, rise ever higher into the sky. Ocean currents slowly change their paths. The atmosphere quietly adjusts. Little by little, the planet begins to cool. At first, the differences are almost impossible to notice. Winters last a little longer, summers become slightly milder. Snow remains on distant mountain peaks long after spring has arrived. Then, over hundreds of thousands of years, that snow begins to accumulate. Each winter adds another thin layer. Each summer melts a little less. The balance has changed. The first great glaciers begin to grow. Imagine standing on the edge of a broad northern valley. Far in the distance, you notice a brilliant white wall stretching across the horizon. It is not a mountain, it is ice. A glacier hundreds of meters thick. Slowly, silently, almost imperceptibly, it moves forward.
Not meters each day, not even meters each month, but over centuries it advances like a frozen river, reshaping everything in its path. Solid rock is ground into fine powder beneath its enormous weight. Ancient forests disappear beneath thick sheets of ice. Rivers are forced into new channels. Valleys become deeper and wider. The landscape itself is being carved by frozen giants. This is the beginning of one of Earth's great ice ages. Over time, enormous ice sheets spread across much of North America, Northern Europe, and large parts of Asia. Some glaciers become more than 3 kilometers thick. So much water is locked away as ice that sea levels fall dramatically. Coastlines move outward. Wide land bridges emerge between continents. One of the most famous is the Bering Land Bridge, connecting Siberia and North America. At this point, however, it is simply another cold, windswept plain. No one yet knows how important it will eventually become. Life must adapt. Some animals retreat toward warmer regions. Others evolve remarkable ways to survive the cold. Imagine a vast open plain beneath a pale winter sky. Snow stretches to every horizon. A cold wind sweeps across frozen grasslands. In the distance, enormous shaggy creatures move slowly through the snow. These are woolly mammoths. Their long, curved tusks glisten beneath the weak sunlight. Thick fur protects them from freezing temperatures. Beneath that fur lies a dense layer of fat, keeping precious body heat from escaping. Nearby, herds of woolly rhinoceroses graze upon hardy grasses that poke through the snow. Huge bison roam the plains. Muskoxen huddle together against icy winds. Powerful predators also thrive in this frozen world.
The saber-toothed cat stalks quietly through the grasslands. Its long canine teeth make it one of the most recognizable hunters of the Ice Age. Not far away, enormous short-faced bears patrol the landscape. Dire wolves hunt together in coordinated packs. Every creature has adapted to this demanding environment. Every day is a struggle against the cold. Yet despite the harsh conditions, these frozen landscapes are full of life. The Ice Age is not simply a world of endless snow. Between the glaciers lie vast grasslands rich with hardy plants. Scientists often call this ecosystem the mammoth steppe. It supports countless grazing animals and the predators that follow them. The sky remains clear. The air is crisp. The world feels both beautiful and unforgiving. Far away in Africa, however, another story is quietly unfolding. Hidden among scattered forests and open savannas, a small population of intelligent primates is beginning to change. Unlike the mammoths or saber-toothed cats, they possess no enormous claws, no thick fur, no massive tusks. Their greatest strength lies somewhere entirely different, inside their growing minds. And in the next part of our journey, we will meet these remarkable ancestors, whose first uncertain footsteps will eventually lead to villages, civilizations, and the modern world we know today.
As our peaceful journey continues, the frozen world stretches farther than the eye can see. Towering glaciers still dominate much of the northern continents. The winds remain cold, the winters are long. Yet beneath this icy landscape, something extraordinary is quietly unfolding. Not another giant animal, not a new predator, but a new kind of mind. Far to the south, across the grasslands and scattered forests of Africa, small groups of early human ancestors are beginning a journey unlike any other in Earth's history. At first glance, they appear unremarkable. They are neither the fastest nor the strongest creatures on the planet. They possess no thick fur to protect them from winter, no sharp claws to defend themselves, no enormous teeth to frighten predators. Instead, they rely on something almost invisible, their ability to think. Imagine standing on an African savanna nearly 2 million years ago. Golden grasses sway gently beneath the morning breeze. Acacia trees cast small islands of shade across the open landscape. In the distance, elephants slowly move towards a watering hole. Antelope graze peacefully. Lions rest beneath scattered bushes, waiting patiently for evening. Among this familiar scene, a small group of early humans walks carefully across the plain. They travel together. Adults remain close to children. The oldest members quietly watch the horizon for danger. Unlike many other animals, they do not depend entirely on instinct. They observe, they remember, they learn. One individual discovers that a sharp stone can cut meat more easily than bare hands. Another realizes that a sturdy branch can be used to dig roots hidden beneath the soil. These simple discoveries are shared with others. Knowledge is no longer lost when one generation dies. It begins passing from parents to children.
From one family to another. For the first time in Earth's history, information itself becomes a survival tool. As thousands of generations pass, these early humans continue changing. Their brains slowly grow larger, their hands become more skillful, their communication becomes increasingly complex. Simple sounds gradually develop into meaningful language. Around evening campfires, stories begin to appear. Warnings about dangerous animals, memories of distant rivers, lessons about seasons and migration.
Although no written words exist yet, history has already begun living inside human minds. One of humanity's greatest discoveries arrives almost by accident: fire. At first, early humans probably encounter flames started by lightning strikes. Most animals flee from burning forests. Humans do something different. They watch, they learn. Eventually, they discover how to carry burning branches back to their camps. Much later, they learn how to create fire themselves. The gift of fire changes everything. Cold nights become warmer, dangerous predators hesitate to approach glowing flames. Food becomes easier to digest when cooked. Families gather together after sunset, sharing warmth beneath the stars. The long evenings encourage conversation. Ideas spread, cooperation grows stronger. Meanwhile, the Ice Age continues shaping the world around them. Glaciers slowly advance, then retreat. Sea levels rise and fall. During colder periods, wide land bridges connect regions that are separated by oceans today.
Patiently, generation after generation, humans begin exploring beyond Africa. Small groups travel into the Middle East. Others continue into Europe and Asia. Many thousands of years later, adventurous families cross the cold grasslands of the Bering Land Bridge, eventually reaching North America. No one knows they are entering a completely new continent. They simply follow animals, rivers, and seasons. Over countless generations, humans spread across nearly every corner of the earth. Some settle beside great rivers, others adapt to deserts. Many learn to survive in frozen northern forests. Some eventually reach distant islands by simple boats. Each new environment teaches fresh lessons. Each challenge encourages new ideas. Despite their growing intelligence, these early humans remain deeply connected to nature. The rhythm of life follows the rhythm of the seasons. They watch the stars. They follow migrating herds. They understand rivers, winds, and changing weather. Every sunrise brings uncertainty. Every successful hunt is a reason for gratitude. As the Ice Age slowly approaches its final chapters, Earth's climate begins warming once more. The massive glaciers gradually retreat toward the poles. Rivers swell with melting ice. Forests spread into lands that had been frozen for thousands of years. The great mammoths, woolly rhinoceroses, saber-toothed cats, and many other magnificent Ice Age animals slowly disappear from history. Some cannot adapt to the warming climate. Others face increasing pressure from skilled human hunters. Another great age quietly comes to an end. Yet for humanity, an entirely new chapter is just beginning. No longer content simply to follow nature, people will soon begin changing it. They will plant seeds, domesticate animals, build permanent homes, create villages, and before long, those villages will grow into the first civilizations the world has ever known. Our next journey will carry us from wandering hunters to the builders of cities, where the story of human civilization truly begins.
As the last great glaciers slowly retreated toward the poles, the Earth entered a warmer and more familiar age. The frozen landscapes that had dominated much of the northern hemisphere gradually gave way to forests, grasslands, rivers, and lakes. Sea levels rose once again, covering many of the ancient land bridges that humans had once crossed on foot. The world was changing, and for the first time, humans were no longer simply adapting to those changes. They were beginning to shape them. Imagine standing beside a peaceful river about 12,000 years ago. The morning mist rises gently from the water. Birds sing from nearby trees. Wild grasses sway in the breeze, their golden seeds sparkling beneath the early sunlight. A small group of families has made camp nearby. Unlike their ancestors, they do not seem eager to move on. They return to this same place year after year. The river provides fresh water. Fish swim beneath its calm surface. Animals regularly visit its banks. Wild grains grow in abundance nearby. For generations, these people have gathered seeds from the surrounding fields. Then, one quiet season, someone notices something remarkable. Seeds dropped near the camp have begun growing into new plants. Perhaps it happened by accident. Perhaps someone intentionally scattered them. No one can know for certain. But this simple observation changes human history forever. Instead of searching endlessly for food, people begin learning how to grow it. Tiny gardens appear beside rivers. Families clear small patches of land. They plant seeds. wait patiently, and months later they harvest their own crops. It is one of the greatest revolutions our species has ever experienced. Agriculture. As farming improves, another important discovery follows. Some wild animals can be tamed. Gentle sheep begin living near human camps. Goats provide milk. Dogs, whose ancestors once hunted beside humans, become trusted companions and protectors.
Later, cattle are raised for food, labor, and transportation. For the first time, people no longer depend entirely upon hunting. Food becomes more predictable. Children survive more often. Communities slowly grow larger. Imagine returning to the same river hundreds of years later. The temporary camp has disappeared. In its place stands a small village. Simple homes made from mud bricks and wood line narrow pathways. Smoke rises peacefully from cooking fires. Children laugh as they help gather grain. Craftsmen shape pottery from wet clay. Others weave baskets or repair tools made from polished stone. Life has become wonderfully different. Because people no longer need to travel constantly, they begin collecting possessions. Pottery stores food safely. Stone buildings last for many years. Knowledge remains in one place, allowing each generation to build upon the achievements of the last. Specialized jobs begin to appear. Some people become skilled farmers. Others focus on making tools. A few become expert builders or healers. Communities become increasingly organized. As villages continue growing, cooperation becomes essential. Fields require irrigation, rivers sometimes flood. Food must be stored for difficult seasons. Disagreements need peaceful solutions. Gradually, respected leaders emerge. Not powerful kings, not yet. Simply trusted individuals who help organize daily life. The rhythm of the seasons shapes every aspect of existence. Spring brings planting, summer nurtures growing crops. Autumn fills storage houses with harvests. Winter becomes a season of storytelling, repairing tools and preparing for another year. For the first time in human history, many families spend their entire lives in the same community. They know every tree, every river bend, every neighboring family. These villages slowly become homes in the deepest sense of the word. As centuries pass, some settlements continue expanding. Hundreds of people become thousands. Simple footpaths turn into busy streets. Trade begins connecting distant communities. People exchange grain for stone, clay pottery for seashells, animal hides for beautifully crafted tools. The world is becoming increasingly connected. With larger communities come greater challenges. How can food supplies be counted? How can agreements between traders be remembered? How can important events be preserved long after the people who witnessed them are gone? These questions inspire one of humanity's greatest inventions, writing. The first simple symbols scratched into clay will eventually grow into books, libraries, science, history, and every story ever written. Human civilization is taking its first steady steps. The rivers that once guided wandering hunters are now nurturing cities. And among all those ancient rivers, one region will soon become known as the cradle of civilization. There, beside the mighty Tigris and Euphrates rivers, humanity will build its first great cities, create the earliest written language, establish laws, and begin recording history itself. That remarkable chapter awaits us in the next part of our journey. As our journey continues, the small farming villages grow steadily larger. Generations pass. Children become parents. Parents become grandparents. The tiny settlements beside peaceful rivers slowly transform into thriving towns. For the first time in Earth's long history, thousands of people live together in permanent communities. The rhythm of life changes once again. No longer does every family produce everything they need. Some people become expert farmers. Others shape clay into beautiful pottery. Some work with copper, creating stronger tools than polished stone could ever provide. Others spend their lives weaving cloth, building homes, or caring for animals. Each person contributes something different. Together, they create societies far more complex than anything humanity has known before. Imagine arriving at one of these early cities nearly 5,500 years ago. The morning sun rises above wide riverbanks. Narrow streets gradually fill with people beginning their daily work. Merchants arrange baskets filled with grain, dates, and vegetables. Potters display rows of carefully crafted jars. Children carry water from nearby wells. Builders repair mud brick walls warmed by the golden sunlight. The city is alive.
not with noise and chaos, but with quiet purpose. At the center of many communities stands an impressive temple. These sacred buildings become places not only of worship, but also of learning, trade, and administration. Respected priests carefully observe the skies. They notice patterns in the movements of the sun, moon, and stars. Season after season, they begin predicting the arrival of floods and the changing of the seasons. Astronomy is quietly taking its first steps.
Nearby, another remarkable invention is changing human life forever. Writing. At first, it is wonderfully simple. A merchant presses a small reed into soft clay to record how many baskets of grain have been traded. A farmer marks the number of sheep owned by a family. Simple pictures gradually become symbols. Symbols slowly develop into written language. For the first time, knowledge no longer depends entirely upon memory. Ideas can survive long after their creators are gone. Stories, laws, trade agreements, religious beliefs, all begin finding permanent homes upon clay tablets. History itself has learned how to remember. As trade expands, distant civilizations become connected. Boats travel along great rivers carrying grain, pottery, timber, and precious stones. Caravans cross deserts with salt, copper, and colorful fabrics. People who have never met exchange ideas through the goods they create. The world grows smaller. Knowledge spreads farther than ever before. With growing populations come new responsibilities. Communities establish rules to reduce conflict. Fair systems for measuring grain and land appear. Leaders organize irrigation canals that bring life-giving water to distant farms. Large construction projects require hundreds of workers cooperating together. Human society becomes increasingly organized. Yet nature continues reminding everyone who is truly in control. Sometimes rivers flood too early. Sometimes they fail to flood at all. A single season of poor harvests can bring great hardship. People learn patience, preparation, cooperation. The greatest civilizations succeed not because they conquer nature, but because they learn to live alongside it. Far beyond these fertile river valleys, other remarkable societies are also beginning to flourish. Along the banks of the Nile, communities thrive beneath the dependable rhythm of annual floods. To the east, great civilizations emerge beside the Indus River. Farther away, ancient cultures develop independently in China and later in the Americas. Though separated by thousands of kilometers, each discovers similar truths. Rivers bring life. Farming creates stability. Knowledge grows when people work together. Humanity is entering an extraordinary new age. The Earth that once belonged to microscopic organisms, then to giant reptiles, then to wandering hunters, now welcomes builders, writers, artists, engineers, and dreamers. Cities continue rising. Trade routes stretch across continents. Kingdoms begin appearing. Some will flourish for centuries, others will quietly fade into history, but each will leave behind ideas that shape the future. Soon, mighty pyramids will rise above the deserts of Egypt. Great libraries will preserve humanity's knowledge. Powerful empires will connect distant lands. And the story of civilization will continue growing, one generation at a time. In our next chapter, we will travel through the age of the great ancient civilizations, where humanity begins constructing monuments so extraordinary that many still stand beneath the same sky today. As diverse cities continued to grow beside the world's great rivers, humanity entered an entirely new chapter. The scattered villages of earlier ages slowly became kingdoms. Kingdoms expanded into powerful civilizations. Ideas traveled farther than ever before. Trade connected distant peoples. Knowledge accumulated with each passing generation. For the first time, history was no longer carried only in memories. It was written down. Imagine sailing quietly along the Nile River nearly 4,500 years ago. The early morning sun paints the water with golden reflections. Palm trees sway gently along the riverbanks. Farmers harvest grain from fertile fields, enriched by the Nile's annual floods. Small wooden boats drift peacefully between villages.
Far in the distance, enormous stone structures rise above the desert horizon. The pyramids. Even today they inspire wonder. Built stone by stone over many years, these incredible monuments were engineering achievements unlike anything the world had ever seen. They remind us that patience, planning, and cooperation can accomplish extraordinary things. While Egypt flourished beside the Nile, another remarkable civilization grew between the Tigris and Euphrates rivers. This region, known today as Mesopotamia, became home to cities such as Ur and Babylon. Here, scholars carefully observed the stars. Mathematicians developed systems for measuring time. Early laws were written so that justice would not depend only upon memory. The famous Code of Hammurabi became one of humanity's earliest written legal codes, showing that societies were becoming increasingly organized. Far to the east, the Indus Valley civilization built carefully planned cities with straight streets, drainage systems, and public wells. Thousands of kilometers away, ancient China developed along the Yellow River, where bronze craftsmanship, silk production, and early philosophies slowly transformed society. Although these civilizations rarely met one another, they solved many of the same problems. How should food be stored? How should cities be governed?
How can knowledge be passed to future generations? Different cultures found different answers, yet all contributed to the growing story of humanity. As centuries passed, trade routes expanded across deserts, mountains, and seas. Merchants carried spices, precious stones, metals, cloth, and ideas. Along these routes traveled languages, inventions, beliefs, and discoveries. The world slowly became more connected than ever before. Knowledge no longer belonged to a single city. It became humanity's shared inheritance. Imagine walking through a busy marketplace in one of these ancient cities. The air carries the scent of fresh bread and fragrant spices. Craftsmen shape beautiful pottery. Metalworkers carefully hammer glowing bronze into tools and ornaments. Scribes sit quietly, recording transactions onto clay tablets or papyrus scrolls. Children laugh as they follow their parents through crowded streets. Life feels familiar despite the thousands of years separating it from our own. People still hope for peaceful families, good harvests, healthy children, a better future. The details of life have changed, the dreams have not. Great libraries begin collecting knowledge from many generations. Astronomers map the movements of stars. Engineers design irrigation systems. Builders construct temples, palaces, bridges, and monuments that stand for centuries. Artists decorate walls with colorful paintings. Musicians perform melodies whose echoes have long since faded into history. Civilization becomes more than survival. It becomes creativity, curiosity, and imagination. Yet as kingdoms grow stronger, they also begin competing with one another. Borders expand, armies march, empires rise. Some rulers seek peace through trade and diplomacy, others pursue conquest. History becomes filled with both remarkable achievements and difficult conflicts. Still, every generation adds something valuable: new inventions, better farming methods, more accurate calendars, improved writing, mathematics, medicine, architecture. Little by little, humanity learns more about the world around it. The Earth, which had spent billions of years shaping life, now watches as one of its newest species begins reshaping the planet in return. Fields replace forests, roads connect distant lands, ships cross open seas. Ideas travel farther than any person could walk. The pace of change continues accelerating. Soon, new civilizations in ancient Greece and later Rome will explore philosophy, science, engineering, democracy, and law in ways that influence much of the modern world. Their ideas will survive long after their cities have changed. As our journey continues, humanity steps into an age of remarkable ideas. The great civilizations of Egypt and Mesopotamia have shown that people can build cities, create writing, and organize powerful kingdoms. Now another transformation begins. This time, the greatest changes are not made only with stone or bronze. They are made with questions. Imagine standing beside the sparkling blue waters of the Aegean Sea about 2,500 years ago. Small ships drift between rocky islands. Busy marketplaces fill with merchants, travelers, and scholars. In the city-states of ancient Greece, people gather not only to trade goods, but also to exchange ideas. They ask questions about nature, about justice, about mathematics, about the stars, about what it truly means to live a good life. Some of the world's earliest philosophers encourage people to observe, reason, and debate rather than simply accept every tradition without question. Their conversations become the foundation of many future discoveries in science and philosophy. Further west, another civilization quietly grows stronger. The city of Rome begins as a small settlement beside the Tiber River. Over centuries, it expands into one of the largest empires the world has ever known. Roads stretch across thousands of kilometers. Stone bridges cross wide rivers. Aqueducts carry fresh water into crowded cities. Roman engineers build structures so strong that many remain standing even after 2,000 years. Merchants travel safely across vast networks of roads. Ideas spread more quickly than ever before. As generations pass, empires rise and fall. The Western Roman Empire eventually declines, and Europe enters a long period often called the Middle Ages. Castles rise upon hills. Small villages surround churches and marketplaces.
Life becomes quieter in many regions, yet knowledge does not disappear. Across Europe, Asia, the Middle East, Africa, and other parts of the world, scholars continue preserving ancient books, improving mathematics, studying medicine, and observing the heavens. Human curiosity never truly sleeps. Then comes another great turning point. Brave sailors begin exploring oceans that many once feared crossing. New sea routes connect distant continents. Maps become more accurate. Cultures that had lived separately for thousands of years meet one another more frequently. Trade expands across the globe. Along with valuable knowledge and new crops, these encounters also bring conflict and disease, reminding us that history is often both inspiring and difficult. Soon, another quiet revolution begins. This one takes place inside workshops and factories. During the Industrial Revolution, machines gradually replace much of the work once performed entirely by human hands. Steam engines power trains. Factories produce goods more quickly than ever before. Cities grow rapidly. Railways connect distant regions. Electricity eventually lights homes and streets. Telephones allow voices to travel across great distances. Within only a few generations, humanity transforms daily life at a pace never seen before. The 20th century brings astonishing achievements. Aeroplanes carry people across continents in hours instead of months. Doctors discover new medicines that save millions of lives. Computers begin processing information faster than any human mind could manage alone. Then, on a clear day in 1969, humanity takes another extraordinary step. For the first time, human beings walk upon the moon.
Looking back from its quiet surface, they see something breathtaking. Not nations, not borders, not cities, only one beautiful blue planet floating peacefully in the darkness of space. Earth, the same Earth that formed from swirling dust over 4.5 billion years ago. The same Earth that survived asteroid impacts, global ice ages, volcanic catastrophes, and countless extinctions. The same Earth that patiently watched tiny microbes become forests, dinosaurs, mammals, and finally curious human beings capable of wondering where they came from. Today, satellites circle high above our world. Powerful telescopes explore distant galaxies. Scientists continue uncovering secrets hidden within rocks, fossils, oceans, and stars. Yet despite all we have learned, Earth still holds countless mysteries waiting to be discovered. Perhaps the greatest lesson from this remarkable journey is not how quickly life changes, but how patiently it evolves. Every mountain, every ocean, every forest, every living creature, and every person alive today is part of a story billions of years in the making. As tonight slowly comes to an end, imagine our planet quietly turning beneath the stars. The waves continue reaching distant shores. The wind still moves gently through ancient forests. The moon still circles faithfully overhead. Long after we fall asleep, Earth will continue its peaceful journey through the universe, carrying every future sunrise with it. And perhaps somewhere far in the future, new chapters of this extraordinary story are still waiting to be written. Thank you for joining this gentle journey through the complete history of Earth. Now, as the world continues turning quietly beneath the night sky, you can simply close your eyes, take one slow, peaceful breath, and drift gently into sleep, knowing that you are part of the most extraordinary story our planet has ever told.
As our gentle journey comes to its final chapter, let us slow down once more. The Earth continues turning beneath the same stars. The oceans still rise and fall with the moon. The winds still cross mountains that have stood for millions of years. And somewhere, while you are listening tonight, another sunrise is quietly reaching a distant shore. We often think of history as something locked safely in the past. But Earth's story has never truly ended. It is still being written. Every gentle rainfall, every growing forest, every newborn child, every tiny shell resting upon a quiet beach, each becomes another small sentence in a story that began more than 4.5 billion years ago. Perhaps the easiest way to understand that immense history is to imagine it as a single day. Picture Earth's entire lifetime compressed into just 24 hours. The planet forms shortly after midnight. The first oceans appear before dawn. Simple life quietly arrives during the early morning. For most of the day, nothing larger than microscopic organisms exists. The oxygen revolution unfolds during the afternoon. Complex animals do not appear until late in the evening. The dinosaurs arrive only a little before 11 o'clock at night. They rule the Earth for what feels like an eternity. Yet on this imaginary clock, they disappear only minutes before midnight. Modern humans, all of recorded history. Every city,
Every kingdom, every invention, every poem, every song, every book ever written. They all occur during the final few seconds before the clock reaches midnight. When viewed this way, our own lives become wonderfully small. Not insignificant, simply brief. Now imagine Earth's history as a single calendar year. The planet forms on the first day of January. The first life appears sometime in spring. Complex animals do not arrive until late November. Dinosaurs dominate much of December. They disappear on December 26. Modern humans arrive only during the final hours of December 31. Recorded history occupies only the final minute before the new year begins. And your own lifetime? Less than the blink of an eye. Yet even the briefest moment can hold extraordinary meaning. The mountains we admire today will not remain forever. Wind and rain patiently wear them down. At the same time, new mountains continue rising, where tectonic plates slowly collide. The continents themselves are still moving. Every year they drift only a few centimeters, too slowly for us to notice. But given another 100 million years, the map of the world will look completely different. The Atlantic Ocean may become wider. Other oceans may slowly begin closing. New coastlines will emerge. Old islands may disappear beneath rising seas. Nature has never stopped changing. Millions of years from now, many animals alive today will exist only as fossils. New species will evolve. Others will quietly fade away. Forests will shift. Deserts may bloom. Coral reefs may appear in places that are now far from tropical waters. Life will continue adapting, just as it always has.